Hello students. Great to see you all again. Today we continue with Gravitational Force, Part 3. Before we get started, let's do a quick refresher on what we learned last time. In our last class, we talked about G, the universal gravitational constant, which is a fixed value used to calculate the gravitational force between two objects. We also discussed the solar system, which includes the Sun, planets, moons, comets, asteroids, and other celestial bodies that revolve around the Sun. These objects are held together by the force of gravity, with the Sun being the central and most massive object in the system. Finally, we learned about Kepler's laws of planetary motion, which help us understand the relationship between a planet's distance from the Sun and how long it takes to complete one orbit. Today's goal is to explore the concept of natural and artificial satellites, as well as their escape velocity. We are exploring satellites. So, what is natural satellites? A natural satellite is a space object that orbits a planet without human intervention, like our moon. It reflects sunlight and helps control ocean tides. In contrast, artificial satellites are man-made and launched into orbit for specific tasks. The first artificial satellite, Sputnik 1, was launched by the Soviet Union in 1957, beginning a new era in space exploration. To launch a satellite into space, we use rockets. These rockets launch vertically, carrying the satellite above Earth's atmosphere. When it reaches the right height, the satellite is released and begins orbiting the Earth at high speed. For instance, NigeriaSat-1 was launched into space to assist with agriculture and mapping. This example shows how countries use space technology to solve local problems. Let's connect the dots between these ideas. Satellites are placed in different orbits depending on their mission. A geosynchronous satellite orbits the Earth once every 24 hours. It stays fixed over one area and is perfect for communications and live broadcasting. Low Earth orbit satellites, like the Hubble Space Telescope, orbit closer to Earth and are great for imaging and research. Satellites are everywhere in our modern lives. They provide communication for phones and the internet. They help monitor the weather, assist in scientific research, and allow us to map the Earth accurately. With GIS, we analyze land and resources. And thanks to GPS, we can navigate anywhere, from finding a new restaurant to tracking global flights. You're making progress, keep it up. Let's talk about escape velocity. This is the minimum speed an object must reach to completely break free from Earth's gravitational pull. Imagine throwing a ball into the air, it always comes back down. That's because gravity keeps pulling it back. But if you could launch that ball at a speed of 11.2 kilometers per second, that is 7 miles per second, it would have enough energy to escape Earth's gravity entirely, and it would never return. This speed is called escape velocity. It's the critical speed rockets must achieve to leave Earth's atmosphere, and journey to the Moon, Mars, and other planets. To calculate escape velocity, we use the formula V equals the square root of 2 times g times r, where v stands for escape velocity, the minimum speed needed to break free from a planet's gravitational pull. G is the acceleration due to gravity on Earth. That's 9.8 meters per second squared. And r is the radius of the planet. In this example, we are calculating the escape velocity from the surface of the Earth, using the formula, escape velocity equals the square root of 2 times g times r, where g is 9.8 meters per second squared, and r is the Earth's radius 6.4 times 10 raised to the power of 6 meters. Substituting the values in, we get the square root of 2 times 9.8 times 6.4 times 10 to the power of 6, which equals the square root of approximately 1.2544 times 10 to the power of 8. Taking the square root, we get approximately 1.1191 times 10 to the power of 4 meters per second, or about 11.2 kilometers per second. So, that's the speed you'd need to break free from Earth's gravity. Congratulations on completing this lesson. You should be proud of yourself. Test your knowledge with these questions. They are perfect for strengthening your understanding of the topic. In summary, we delved into the fascinating topics of natural and artificial satellites, as well as the concept of escape velocity. I hope you found the session both engaging and informative. In our next class, we'll move on to explore the concept of the electric field. Thank you.